Hello students, welcome to our another class of electricity and magnetism. In this chapter, we are at almost the end of this chapter. In our previous class, we studied about transformer. We studied it in detail. We looked at its construction, what were the key components for a transformer. We looked at the principles on how it works as well. And so today we will be focusing on the types of transformers, which are step up and step down, and some numerical problems related to it. We shall again recall something about transformers as well, but before that, let me show you this diagram. The first image, you have already seen this, right? We tried to solve some imaginary situation in our previous class using this first image. Okay, so now let me tell you. In case of first image, this charger delivers 5 volt of EMF so that your mobile phone can get charged. So your mobile phone requires 5 volt. On the second image, you can see it is a microwave oven, and this oven, we use it for cooking food, heating food and all, right? So this oven requires more than 2000 volt, meaning it requires higher voltage to do its work efficiently. And in our house, the power supply is of 220 volt. So in these two situations, one requires low voltage, one requires higher voltage. And we know that we use transformer to alter the voltages. So that means to let's see what do we use to increase the output voltage or decrease the output voltage according to our required situation. Today we will be focusing on that. So before that, let's recall about the definition of the transformer. It is a device that modifies the voltage of an alternating current without altering its frequency, and it is widely used in power transmission and distribution systems to either increase or decrease the voltage level. So it only increases or decreases the voltage level, but it does not alter the power or the frequency provided by the AC source. It just alters the voltage, and it maintains the same power by altering the current. So talking about the working, it works on the principles, basic two principles, which are electromagnetic induction and mutual induction, where mutual induction means the phenomenon in which a varying current in one coil generates an electromotive force in a neighboring coil through electromagnetic induction. So let me recall you about transformer. In case of transformer, a soft iron core is used. So there were plates of iron cores, right, which were laminated by some insulating substances, and then those plates were stacked together to form the core of a transformer. And on the either sides were the windings. The windings, we had to identify whether they were the primary coil or the secondary coil. So for this, let's look at the definition of the primary coil. So primary coil is the coil of the transformer that is connected to the input AC voltage source, and it receives electrical energy and creates a changing magnetic field in the core. So how do you identify a primary coil in a transformer? The primary coil is the one that is connected to the input source. So if we use AC source on a certain side of the transformer using a certain winding of the transformer, that side is the primary coil. It receives certain electrical energy, and what happens? It creates a changing magnetic field. Because we are using AC source, the alternating current periodically changes its direction, which again constantly keeps on changing the magnetic polarities and strength, which again induces EMF on the neighboring side of the coil, which is the secondary coil. So what is the secondary coil? Secondary coil is the coil where the output voltage is induced. It delivers the transformed voltage to the external circuit. So, source is connected to the primary coil. That is what we are using. Now, according to your requirement, we can change the number of windings on the secondary coil and get the required voltage on the output side, right? So, while recalling about this, let's see the number of turns. We are talking about the primary coil. What are the key components in a transformer? Yes, a basic one, soft laminated iron core, a primary coil, secondary coil. The primary coil and secondary coil are also insulated because we do not want any short circuits to happen during the working. So they are kept a bit further and they are insulated properly. Now, the number of turns in the primary coil, the coil which is connected to the AC source, is denoted by NP. And the number of turns in the secondary coil where the output is connected is denoted by NS. The primary voltage is the voltage which is received by the primary coil, that is VB, and the secondary voltage is denoted by BS. So, now in a transformer, the ratio of the number of turns in the primary coil to the number of turns in the secondary coil is equal to the primary voltage to the secondary voltage. Let's look at this expression mathematically. It says NP by NS equals to BP by VS. We can see a kind of direct proportionality with the turns and the voltage, right? So, we will again study further about the effects of this number of turns on the either side. But before proceeding further, let me show you this image. I left you with this image in the earlier class, right? So here you can see in this generation plant, one transformer is connected here. This is a high voltage transmission line, and here you can see another transformer, and these are the poles, electrical poles near our home. See, first near the generation plant, once the current or EMF is induced in this generator, a transformer is used to transmit this voltage, right? And when it reaches to the substation, further this voltage is transferred to the electrical poles around our houses. And near our electrical poles, there is another transformer which again alters the voltage level. Now, let's see, our question was of the previous class. Think about how electricity travels from power stations to our homes. Does it need high voltage or low voltage at different points? Now, let's see. Okay, let me give you an example of hydropower. So in hydropower, what happened? Above a certain height, we left the water to flow. The water flew through a penstock, a very small tube-like path. It flowed through the penstock and then it rotated the fans of the turbines. That turbine was further connected with the armature, and that armature was connected with the generator. So now when the water flows and then rotates the turbine is rotating the armature as well. So that armature is again helping to create a kinetic energy inside the generator, which further generates alternating current. Now, after the alternating current is generated, it has to be distributed to us, right? So how does this generated electricity reaches our home? Let's look at here. So let's say this is a generation plant, and in this transformer, see, induced voltage is passed to this transformer. Here we are using a transformer which increases the the value of the voltage quite highly. So when the induced voltage reaches in this transformer, it increases the voltage at a very high voltage, and then these transmission lines are used to reach the sub power station. So from the power station, high voltage transmission is used because the voltage that is transferring from this power station to the substation is quite high. So once this very high voltage, once this very high voltage reaches to the other transformer, the voltage, by altering the number of turns, the voltage is decreased slightly. The output voltage in this transformer is comparatively low to this transformer. So this transformer, the output voltage in this transformer is quite high. When it reaches here, the output voltage decreases slightly, and when it reaches to the electrical poles, on the electrical poles also you can see the transformer, right? So another transformer further deduces the voltage and then it is supplied to our home. So in our home we are supplied with 220 voltage, and according to the requirements of our electrical appliances or the electrical equipments that we are using, certain required transformers are used in our devices as well. So we can see the working is same, the making is same, but the transformer is being once used to increase the voltage and the other time it is used to decrease the voltage. So you remember this diagram, right? This was a 2D diagram of our transformer. This is the iron core plate and it is not just one. Here are stacks of such laminated iron core. So why did we use this laminated iron core? Do you remember? So we use this laminated iron core to reduce the loss of energy in the form of heat, and we are using this ferromagnetic core so that the magnetic flux can pass towards the secondary coil from the primary coil very easily, and also it also strengthens the magnetic field. So now you can easily recognize a primary and secondary coil as well. The coil that is connected with the AC source, this is the primary coil, and the one that is connected with the load is the secondary coil. Now we were talking about increasing the voltage, decreasing the voltage. Based on the alteration of the voltage, we have basically two types of transformer. The first one, let's see, it is a step-up transformer. Let's start with step-up transformer. It is a transformer that increases the voltage from the primary coil to the secondary coil. Now let's see, what does step transformer mean? It has the meaning in its name itself, step up. So you are receiving certain voltage in the primary coil, right? But if you are using step up transformer, the output voltage is going to be up, or let's say it's going to increase. Okay, so that type of transformer which increases the voltage from the primary coil to the secondary coil is known as step up transformer. So primary coil has fewer number of turns compared to secondary coil. So we were telling that the number of turns determine whether the voltage is going to increase or whether the voltage is going to decrease. So if in case of step up transformer, since the output voltage is more than the input voltage, the number of turns in the secondary coil is more. So primary coil has very few number of turns in comparison to the secondary coil. Okay, so what is a step up transformer? Step up transformer is the transformer which is used to increase the output voltage, and since we are increasing the output voltage and we know that it is directly related with the number of turns, if the output voltage is more, then obviously the number of turns in the secondary coil is also more. So there are less number of turns in the primary coil. So similar to this and quite opposite, let's look at what a step down transformer is. Again, it has its meaning on its own name. step down transformer. So it is a type of transformer which decreases the voltage from the primary coil to the secondary coil. So in the primary coil, a certain amount of voltage is being received, but we do not want that. We want a quite less voltage for our appliances, right? So in this case, step down transformer is quite useful, right? So what happens now when step down the output voltage, if you compare, the output voltage is lower than the input voltage, so it reduces, or let's say it decreases the voltage from the primary coil to the secondary coil. So with that, obviously the primary coil has more number of turns compared to the secondary coil, as I already mentioned before. So wherever the voltage is more, the number of turns is also more. In step down transformer, the output voltage is less, right? So if the output voltage is less, obviously the number of turns in the secondary coil is also less, meaning the number of turns in the primary coil is much greater, let's say it's greater than the secondary coil, due to which it reduces the input voltage. Okay, so let's see here. You can see representation of step up transformer, step down transformer. Everything seems to be similar, but if you look at it closely, you will see the major difference of step up transformer and step down transformer. Look at here. In step up transformer, this is the input voltage. The arrow which shows that something is going inside this transformer is denoting the primary coil. So the input seems to be 10 volt AC, right? And you can see the magnetic fields are being generated, and on the output side of this step up transformer, you can see it is greater than the input voltage. It is 20 volt AC. Okay, see, the input is 10 and the output is 20 volt. So obviously the voltage has increased from the primary coil to the secondary coil. Let's look at another case. Here the input is 10 volt, again the same, but the output is 5 volt AC. We can see that these values are different. Now if you look it more closely, you will see that it represents, it is demonstrating the definition that we told earlier. We said that in step up transformer, the number of turns in secondary coil is greater, right? So if you look at here, you can see the number of turns in the primary coils is very much lesser than the secondary coils, right? So again, step up transformer means voltage up, meaning it increases the voltage. Since we are talking about the output voltage, output is connected with the secondary coil, so the secondary coil must have more number of turns. And let's look at here again. Step down means the value of the voltage, or let's say the output voltage, is going to decrease. So the output voltage is going to decrease here in the, so output is connected with the secondary coil, so the number of turns in the secondary coil is less. So the number of turns is determining whether the transformer is step up or step down. So I think now you know the basic definitions of step up and step down transformer, right? So we are going to use certain aspects to know about the differences of step up transformer and step down transformer. Okay, so talking about its function, we know that step up transformer increases the voltage from primary to the secondary. In case of step down transformer, its function, it is to decrease the voltage from primary to secondary. Okay, so this is our first aspect, as we already told that step up increases voltage, step down decreases voltage. So their function is also to alter the voltage accordingly. On the second aspect, it is primary coil turns. So in step up transformer, the number of turns in primary coils are quite fewer, right? Because we are trying to deliver high voltage. So high voltage, high output voltage, output is connected with secondary coil. So in the output there will be more number of turns in case of step-up transformer, meaning the step-up transformers comparatively have fewer number of turns in the primary coil. In case of step down, it is quite the opposite. The number of turns in the primary coil is more in the step down transformer. Now let's talk about the secondary coil turns. Okay, again, since the output is connected with the secondary turns, and if we are going to increase the voltage, the one connected with the output must have higher voltage. So higher voltage, if you want higher voltage, we are going to increase the number of turns, right? So step up transformer obviously has more number of turns in the secondary coil, whereas in case of step down transformer, it has fewer turns in the secondary coil, because step down transformer is here to decrease the voltage, right? So to decrease the voltage, we do not need much more number of turns. Comparatively, it should have less number of turns than the primary coil. So in application, as we have looked at the diagram earlier as well, for application, step up transformer can be seen. It is used for power transmission for high voltage, in using high voltage transmission line, and it is used to reduce loss over long distances. So when we were talking about power, relating it to current and voltage, we said that power is the product of current and voltage, right? So if the voltage is increasing, the current must decreasing, because transformer helps to maintain the power and frequency as well. So we cannot alter the power or frequency, but we have to maintain it by altering voltage. So if the voltage is increased, the current is decreased. So in case of power transmission, you will see step up transformers. Okay, so step up transformers are used because we need lots of voltage to distribute in lots of houses and all, right? So step up transformer increases the voltage. When the voltage is increased, since we are transmitting the power, when the voltage is increased, current is decreased. If the current is decreased for long distances, there is also what? There is less loss of energy. It will help to reduce the loss over the long distances. So step up transformer is very useful for power transmission line, just to reduce the loss over long distances. So now where is step down transformer used? In the earlier diagram also you have seen that step down transformers are used in the sub power station, or let's say substation, and also near our house, in the electrical poles near our house. So step down transformers are used there. Along with that, we can also find step down transformer in household appliances like charger. In our previous class, while introducing you the term transformer, I showed you how a mobile phone was charging using a charger, right? So the work of that charger was to deliver 5 volt to the mobile phone to charge your battery. See, it is receiving 220 volt, right? So it is receiving 220 volt. A transformer is used there along with the rectifier as well, because since it is receiving AC, we need DC to charge our phone. So it receives AC, and with the help of the transformer, the 220 volt is converted to 5 volt, and again with the help of rectifier, AC is converted into DC and it is delivered to the charger, which helps to charge our phone, right? Okay, so talking about the power conservation, like again, let's say it reduces current to minimize power losses during the transmission. Again, let's see, we talked that how power is related with current and voltage, right? And we are not going to alter the power. We have to keep it similar as far as possible. So to reduce the loss of power, we increase the voltage. When we increase the voltage, obviously the current is minimized, right? So power conservation can be also done, because when voltage is increased, current decreases. Whereas quite opposite happens in case of step down transformer. Here in the step down transformer, our output voltage is lesser than the input voltage, right? So if the output voltage is lesser than the input voltage, voltage is decreasing in case of output, right? So if there is lower voltage, we have to maintain the power transmission. So if there is lower voltage, obviously the current is increased. So when voltage increases, current is decreased. When voltage decreases, current is increased. In this way, power transmission, or let's say power conservation, is done in step up and step down. So now we have a depth concept about step up transformer. We know its definition, we know what it does, we know its application, we know about the role of number of turns in these coils as well, and how the power is being conserved in case of both step up and step down. Let's look at some numerical problems. I have highlighted this formula because to solve the numerical problems related to transformer, this formula is quite enough, which is Np by Ns equals to Bp by Bs, where Np is the number of turns in primary coil, Ns is the number of turns in secondary coil, Bp is the primary voltage, and Bs is the secondary voltage. So with this note, let's solve this question. In a transformer, the turn in primary coil is 600 and the source is connected, which has a voltage of 230 volt. What will be the number of turns in the secondary windings to get 60 volt output? We will do this on the board. So here the question has given the turn in primary coil is 600. We have the number of turns in primary coil, meaning the number of turns we are going to represent it as Np. It is 600. And the source is connected which has a voltage of 230 volt. Since the source is connected, the voltage that is given in this question is primary voltage, which is 230 volt. Now what will be the number of turns in secondary windings to get 60 volt output? Here the output voltage is given, which is the secondary voltage and denoted as Vs. Now we have three known parameters. We just have to find the number of turns in the secondary windings. So to do this numerical, we are going to list out the given and then solve it accordingly. So in a transformer, the turn in primary coil is 600. So what is given here? Number of turns in primary coil, which will be denoted by Np, and it is given 600. Secondly, the source is connected which has a voltage of 230 volt, meaning we are given a primary voltage. So primary voltage is denoted by Vp, which is given 230 volt. And what will be the number of turns in the secondary windings to get 60 volt output? So you are given the output voltage as well. That means it is the secondary voltage. Now, the thing that you are trying to find in this numerical is number of turns in the secondary winding, which is the number of turns in secondary coil. Now, we have previously mentioned formula, right? So we have mentioned that Np by Ns equals to Bp by Bs. So it is quite direct. You can simply substitute the formulas, you can simply substitute the values in the formula and solve this question easily. Now, after listing this given, we know Np by Ns equals to Vp by Vs. So NP is 600, NS is unknown, VP is 230 and VS is 60. Now, by simply doing a cross multiplication, now we can further do it mathematically. Okay, let me write this here. Or 230 NS, I am simply doing the multiplication, okay? Okay, so this is what we get after this. Now we will simply divide 36,000 by 230. So after you calculate this, we will get that the number of turns is 156.5. Now let me tell you, here we first listed the given things here, right, given parameters here, and we use this formula. With this formula we did simple cross multiplication and found that the number of turns in the secondary winding is 156.5. But 156.5 cannot be our final answer. Why? Because the number of turns in a coil must always be of integer. We cannot have decimal terms for this. So we have to either round it up or round it down. Since we can see it is 156.5, we can simply round it off to 157. So our final answer is the number of turns in the secondary windings must be 157. 157 to get 60 volt output. So this is a simple numerical question related to transformer. Let's try to solve another one. Okay, now we will try to do our next question. The number of turns in the primary coil of a transformer is triple than that in the secondary coil. Calculate the primary voltage if 220 volt is generated by the secondary coil. Here the number of turns is not given in numerical form, but we have the relation of the number of turns in primary coil and the secondary coil. Okay, so now let's see. Here it is not given the actual number. The number of turns in the primary coil is triple than that in the secondary coil. We are taking the reference of the secondary coil. So we can suppose the number of turns in secondary coil as X. Okay, let's start with the supposition. Okay, now let's say let the number of turns in secondary coil be X. Okay, now we are going to list the given. Now the number of turns in primary coil, I am going to simply write it as NP. Now the number of turns in primary coil is triple than that in the secondary coil, meaning it is 3 times with whatever the number of turn in the secondary coil. So if the number of turns in coil secondary is X, simply NP is 3X. Then calculate the primary voltage if 220 volt is generated by the secondary coil. This is the output voltage, which is also written as BS, which is the secondary voltage. The value is given to be 220 volt. Now see, we have secondary coil as X, right? Let me also list it out. We have the secondary coil as X. The number of turns in secondary coil as X, number of turns in primary coil as 3X, secondary voltage 220 volt, and the primary voltage is to be calculated. So Vp equals to what? Again, we are going to use the same formula. The only extra step was to suppose this secondary coil when we are not given anything, but if we are taking the references of the other coil, we can simply suppose it as X. So again we have NP by NS equals to BP by BS. Okay, now we have to simply replace the values from the given side on this equation, right? So instead of NP, we will write 3x. Instead of NS, we are going to write x. Instead of BP, we have to calculate it. So let us leave, and VS is 220 volt. You can see we can cancel this x and then simply cross multiply it, which will give BP equals to 660, and very important part is unit. You have to always write unit after you solve this numerical. Okay, so last question for today. This one is a diagrammatic question, which is a very common question for grade 10. Study the given diagram and answer the following questions. A. What type of transformer is it? You can figure it out by looking at the number of turns. And question B, why is the iron core of this transformer made laminated instead of being on one solid piece? As we have mentioned in the construction part, that in transformer we use laminated iron core sheets and then stack it together instead of one whole thick iron part, right? So why do we do this, and what type of transformer is this? Try to solve these questions and then show it to your teacher. So we have completed this chapter. Study well, and we shall meet in our next class. Thank you.